Okay, welcome everyone to our lab on fluid viscosity using sodium alginate. I've got my supplies here. I've got some deionized water or distilled water. I've got sodium alginate in powdered form. I've actually pre-mixed a 5% solution of sodium alginate that I'm going to use for the activity, and we'll go over why I've pre-mixed that here in a second. And I've got a scale for measuring out my various weights. I've got some popsicle sticks that I'm going to use both as spatulas and stirring rods. You want to have a good handful of these. It's nice to be able to just kind of toss them as they get dirty. I've got some paper towel to put any dirty equipment, utensils, or things that I'm done with away, and we're ready to get started. First thing we want to think about is this sodium alginate takes a long time to hydrate or dissolve in a solution. And so we want to pre-mix some of this 5% solution that we can then use to make the solutions we'll actually use for the activity. And I'll demonstrate what that looks like here real quick. So if I want to make a 5% sodium alginate solution, I'm going to do 5 grams of sodium alginate, and I'm going to add to that 95 grams of water. So that way it's 5% by weight. I've got my scale here, so I'm going to move some of this out of the way. I'm going to put my container on this. Now I've got glassware here just to make it easy for me to reuse these, but a plastic measuring cup will work just fine. You just want to make sure that whatever you have is big enough to hold the volume you're going to be mixing. You don't want it to be a lot bigger because that's going to make it harder for you to get it all mixed together. And since I'm making about 100 milliliters, this 100 milliliter flask will work well. But I can just easily use a plastic cup or a paper cup. I'm going to zero my scale so that way the weight of the glass is no longer being counted. I'm going to add my 5 grams of sodium alginate. Now I want to get this as close as I can, but I can always adjust the ratio or the amount of water that I'm adding if I would like after the fact. So as you get close, you can do smaller and smaller amounts. Try and get where you want to be. All right, now that I've got my 5 grams of the sodium alginate powder, I'm going to close that up. And I'm going to add my water. Now for my deionized water, I like to use the syringe that we're going to be using later for our fluid testing to measure out the water. To start off on this one, since I'm making 95 grams of water, it would take a long time to add this syringe by syringe. So I'll start just by kind of pouring it in, and then I will lower that to get it more precise as I get closer to my desired target. When you're making this alginate from the powder the first time, you do want to add a little bit of water first, and then after you've mixed it some, add in the rest of the amount. So I'm going to pour in a little bit of this. Try and get to about the same amount of water as I have powder. And you'll notice that this powder really does not want to saturate very easily. So if I look at this in the camera, you can see that I've got a lot of kind of separation of those two parts. If I mix this together, we should be able to get most of this to hydrate. You can see all that kind of liquid is gone. And then I can add a little bit more water to this. Now in this case, I already have 5 grams of alginate here, so I'm going to add until I get to 100 grams total, and again, 5 of those 100 grams, or the 5%, will be the alginate. And I'm just adding a little bit as I go. I do need to take out my mixing implement as I get close to that 100 milliliter mark. And I'm not going to be able to get all of this mixed together on camera today, because you notice we still have a lot of clumps in this, but that's the reason we want to make this solution in advance of our activity, is that if I let this sit overnight, this will go from a clumpy mess to a fairly homogeneous mixture. So we're getting kind of close there. That's looking pretty good. Let's try to get up to that 100 grams. I have to get close to that mark. This one's getting pretty full. So I may stop there for the purpose of the demonstration so I don't make a mess. You can see we've got that sodium alginate powder is still largely kind of floating mostly in clumps inside the solution. And if I let that sit, this will become a fairly homogeneous mixture overnight. So to this mixture, the other thing you might want to do, and this is optional, add just a few drops of food coloring. I like add 4. And this is going to make the fluid a little easier for us to differentiate. It's also going to make those clumps of alginate stand out a little bit better, so I can tell how well mixed together that is. All right, so I'm going to set that to the side. And I've got my pre-mixed 5% alginate. I made this a few days ago. And I'm going to use this for our activity. We notice that this is still quite viscous. It's quite thick. But this is going to be a lot easier for us to mix into our solutions than it would be starting from the powder. The first thing you're going to want to do is you're going to want to decide what percentage of sodium alginate you really want to make. I'll start by making it 2%, but anything between 1 and 4% should work fairly well for this activity. So if you want, pause the video, talk amongst your groups. You do want to make sure that you and some of the people that you're taking or doing the activity with have a range of different concentrations. So if someone in your group is making 1, you can do 2. If they're doing 2, you can do 3, or you can do 1. Take some time and figure that out. Everyone's got their amounts? Good. The next thing we need to do is to calculate how much of our solution, our concentrated solution, do we need to add to make our diluted solution. In this case, if I want to make a 2% concentration from a 5% concentration, I need to add 2 parts of this concentration plus 3 parts, or really 2/5 of my water. I got to add that to the knowledge of how much do I actually want to make. I want to have over 20 milliliters of my final solution to be able to fill this syringe, because there's going to be a lot of material left inside my mixing container that I'm not going to be able to get out. So I'm going to try and put 10 grams of my concentrated solution and 15 grams of water into this container. This is not going to be very easy to measure out exactly, and getting exactly 2% is not that important. But make sure you write down the values that you have for both the concentrated solution and the final weight of the mixture that you're making. Sound good? All right, take a few minutes, plan that out with your group. Make sure everyone has a good idea of how much of each of the concentrated solution at 5% and the water they're going to be adding to make their solutions. All right, let's get started. We're going to zero this again. So again, we want to start at 0 so that we're not including the weight of our cup as we're measuring out. I'm actually going to use 2 of my spatulas, my popsicle sticks, to help me measure this out, especially as I get closer to my desired amount. Again, I'm trying to make 2%, starting from 5%, so I'm going to try and add 10 grams of the concentrated solution. And almost exactly. So what you want to do at this point is, I've gotten pretty close to the amount that I want in there. I want to write down that 10.1 grams before I add anything else. Once I'm done with this, I can pass that to the next person in my group so they can start measuring out their amount, or I can just set it aside and move on to the next part. The next thing I'm going to add is my water. Again, I want to add 15 grams of water, which means I'm going to get to 25 grams total inside this container. Again, as I get close to that amount, what I'm going to do is I'm going to take my syringe, I'm going to draw up about 5 milliliters, a little less than that to fill this out, and then I can slowly add this in to get to my 25 grams. And again, if you overshoot that a little bit or if you decide to stop a little early, that's okay. Just make sure you write down that final weight. So I had 10.1 grams of my concentrate, 25 grams of the total solution. So that should be now a 2% solution after I mix these together. You can notice that these are still fairly separated, but this should mix without too much difficulty now that I've got that 5% starting solution. You are going to have to stir this quite a bit. And as you see this go through, one of the things that's nice about that coloring agent is that you can see, let me move the scale out of the way. You can see where I need to continue to mix a little bit more because those globs of the darker blue have not mixed together thoroughly yet. So I'm just going to mix this for maybe a minute. And once you've got a nice clear consistency, you don't notice any significant globs inside that, you can stop. I do want to try and avoid putting too much bubbles into this, so try not to mix too vigorously. But that should be good. All right, now I've got my 2% solution. I can work with my group members to make sure that they all have their concentrations. And then we're ready to actually measure the viscosity of this fluid. So to do that, I'm going to pull some of the fluid out of my mixing chamber into this syringe. You want to do this nice and slow, and I recommend that you tilt the glass to keep this point of the syringe as close to the bottom as possible. If you try and pull too quickly, what you're going to end up doing is you're going to end up pulling an air bubble into the syringe instead of the fluid. And I don't know if I can get it so you can see this or not. You can see I got the syringe right there on the bottom. And if I pull too quick, you notice it starts to pull a little bit of a almost like a tube that forms of the air coming down into that. So kind of keep that angled and try and keep it so that way you go slow enough, the fluid is able to flow back towards the entrance to that syringe. Now I've got my syringe full. I can take that. I've got a little stand here, but your syringe caps will work just fine with that. I'm going to use that to hold my syringe while I drop my ball bearing into that to see how viscous this fluid is. To get the syringe stopper out of this, what I recommend that you do is pull just a nice big air bubble into there so you've got some space. You can let that float to the top, or you can just pull ahead and pull it out. Is that once I got some air in there, so I can just be able to pull the syringe back pretty easily, and I can actually just pop the whole stopper out and put that on my paper towel. And once I've got that, again, this is a fairly viscous fluid, so I can just go reasonably quickly and put that onto my platform. Once I've got that in place, all I need to do now is to measure how long it takes for this ball to fall through my cylinder. So get with your partner, have them get ready, then when you drop it, have them start, maybe give them a countdown so they're ready, and then when it hits the bottom, stop it. Now the hard part is getting the ball bearing back out. Two ways of doing that. The easy way is I can use my magnet to pull that ball right up and out. Oh, wasn't quite fast enough there. There we go. Or we'll do a drop again. If you don't have a magnet, we can just either try and fish this out with our mixing rod, which can be difficult to do. but it's possible. That's not gonna, we can just invert this whole thing, dump the whole thing out into our mixing container. And then if we want to refill that, again, we'll just go back like we did before and put the syringe back in. After we've measured the time for each of our group members and got the amount of time it took for the ball to drop in their fluid, we want to plot that and compare our results. So I'll let you guys all do that now. Now that we've gone through and made the 1%, 2%, 3%, and 4% concentrations of the sodium alginate, I thought it'd be fun to do a visual demonstration of the difference in viscosity between these fluids of different concentration. Again, these are all the same materials, just with more sodium alginate as a function of the total amount of weight in the 4% here on the right side of your screen than the 1% here on the left side of the screen. Ready? Here we go. So we can see from that pretty obviously that a small change in the percentage of the sodium alginate in the solution makes a big difference in how thick that solution is. Our 1% here drops so quickly that it's almost hard to time how long it takes to get to the bottom. And the 4% here, well, you'll probably be bored of watching this video before it gets to the end. So I hope you enjoyed this activity. Please let us know if you have any questions or comments down below, and we'll see you for the next one. There we go. Thanks for watching.